Today we're going to go through the TShark Basics, which is a part of the SOC Level 1 pathway of TryHackMe, and it's a continuation of the network security and traffic analysis module. We did a lot of videos on WireShark, which was a big piece, and a lot of people love those things, and TShark was recently added to the SOC Level 1 pathway in this specific module because it's basically the command line interface version of WireShark. So I'm really excited about this one. I think we're going to get to learn a lot of good things together. And yeah, that's basically it. So let's talk a little bit about what this whole thing is. So as we already mentioned, WireShark is the developer that created TShark, and it's a command line tool. So the WireShark original tool is a GUI tool. It has a graphic user interface. There's a lot of point and click stuff and drag and drop and all those things that are visually pleasing, but sometimes it can be kind of slow, which is why command line tools are always a really good idea if you're dealing with speed requirements and you need to respond in a timely fashion. And if you're comfortable with the command line, then you end up loving these tools much more, simply because of the fact that they're faster. Now, as they say, it has most of the features of WireShark, so I'm expecting that some of the features are going to be missing, but we're going to find out exactly what those features are together. Some of the learning objectives are to learn to filter traffic with TShark, implement WireShark filters inside of TShark, and expand and automate packet sniffing with TShark. So these are a few things that actually I don't think are even available with the GUI graphic interface of WireShark. So I'm really excited to see what those are all about, and I've already launched the virtual machine that's attached to this, so it should be nice and easy as we move forward. They do recommend the network fundamentals room and the WireShark modules, and I've done the entire network fundamentals pathway as well, so these check marks imply that these are all done. There should be some decent videos on this, although I feel like this was actually way too much of a beginner module, and I may not have done this because there's a lot of things in here that you can find by simple Googling. So if you don't know what networking is, or if you don't know what a LAN is, or if you don't know what the OSI model is, and packets and frames, all those things, if you don't know what those things are, you might want to look into it. I think you can actually find some videos on this channel. It would be at the very beginning of this channel starting, so I'm not exactly sure if I have these or not. But this one for sure, the WireShark Basics room, I know for a fact that I have. So if you actually look up WireShark on the channel, you will definitely find those videos. So that being said, let's actually get this going. Alright, so these are some useful hints for us as we go down the command line path together. All of these things are basic command line tools. So grep, cut, unique, nl, those are all basic Linux command line tools. Cap infos, I think, is actually something that I've never actually used before. It's a program that provides details of a specified capture file. It is suggested to view the summary of the capture file before starting an investigation. So this is not specific to TShark. This seems to be a general command that's available inside of the Linux command line. Sed is the stream editor, and awk is a scripting language that helps pattern search and processing. So these are all actual command line tools and utilities inside of Linux. And grep helps you search through plain text data. Cut cuts parts of the lines from a specified data source. Unique filters repeated lines and values and gives you only the unique values that exist in something, so you don't get repetitions of the same value over and over and over again. You only see all the unique values. And NL views the number of shown lines, so it just shows you how many lines that you got in there. So that is it as far as the tools that we got, these little hints that we got. So the first thing that they want us to do over here is to answer these questions based on the demo pcap file that's on the desktop right here under our exercise files right here. So one of the things that I'm going to do is I'm going to open up this in a new window so that we can look at it easier. And I'm just going to open this up on a separate window so that we get a chance to go back and forth with this. So I'm just going to actually literally move this into my other monitor so that I can see it while we're going through this room together, and then from there we'll be able to get some good exercises, and it'll display well on the screen as well. So let's go back over here and let's go full screen with this, and let's do some command line stuff. All right, typically when I get into a command line, I just want to know where my working directory is. I want to know what's inside of my working directory, and we notice that we have the desktop as the very first thing. So we want to go into our desktop and find those exercise files, which they're right there. And now inside of this, we have one pcap file, which is the demo pcap file. So we're going to run this cap infos command with the demo pcap ng file. And with this information, we should be able to find the answers that we're looking for. So the first thing that they're looking for is the, what is the value? It's the ripe MD 160 value. So the ripe MD 160, which is this thing, and this is one right here. I feel like this is a hash value. So versus MD5, this is probably MD 160. So let's go into this thing right here and let's do that. There we go. Okay, that's the first answer of the exercise. Okay, cool. So that one was fairly quick, fairly easy. Let's move on to the next one. All right, so now the command line tools that actually directly apply to TShark. These are the actual commands and options that apply directly to TShark. So the first one is the -H, and it's usually the help page. So with most tools, -H takes you to the help menu for TShark. -V, for this case, is the version info of VShark. Capital D, -D, gives you the available sniffing interfaces, and -I helps you choose an interface. So you can do -I1 or -I ENS55, which I'm assuming is the name of the actual interface in this particular case. And then no parameter by itself, if you just type TShark and press enter, it starts sniffing traffic very similar to what TCP dump does. So -V gives us the version info. Sniffing is sudo tshark -D, and it shows you the various interfaces that you can scan, and then from there you would choose your option. So no interface argument is an alias for I1. So if you did -I1, would probably give you that. And in this particular case, if you wanted to do just sniffing by itself, you would do tshark, and it starts capturing on ENS5, which is that original interface. So what is the installed version of the TShark that we have? And then list the available interfaces. What is the number of available interfaces that we have? So let's do those specific commands together real quick. All right, first we're going to do tshark v, whoops, like that, and we should get the version info of tshark real quick, or I guess not real quick. Let's see how long that takes to populate. Okay, that took a few seconds, a little bit longer than I wanted it to, but we got it. So 3.2.3, I believe, is the version. So let's see, 3.2.3 is the version. There we go. And what is the number of available interfaces given our VM? So tshark-D would give us that information. And we got 12. Wow. We got a bunch of stuff over here. So 12 interfaces would be our answer for that. Excellent. So, all right, moving on to the next piece. The main parameters of TShark is what we're mostly interested in. And these are things like -R, which would be reading the pcap file. -C would give you a count, so a packet count after a certain number. So if you do stop capturing, filtering, reading 10 packets, for example, it would be tshark C10. And then the W would be the write or the output function. So if you sniff traffic using tshark and then you do W sample capture, it's going to write on this new capture file the traffic that it sniffs inside of that command. Verbose is capital V in this case. So lowercase v gives you the version info, capital V gives you a verbose version of the sniff, which most likely gives you just more details. That's typically what verbose does. It just gives you more details and it gives you more of an output. And then we have Q in silent mode, so it suppresses the packet output on the terminal and it doesn't show you everything on the terminal. I guess it just kind of just starts capturing and it runs in the background in quiet mode and silent mode. And X gives you the bytes of the packet. So it packs the packet details in hexadecimal format and ASCII, ASC dump for each packet. So it gives you a lot of the details of the hexadecimal and AC details inside of the output or displayed onto the screen. So based on what I've gathered about a lot of different command line tools, you can combine a lot of these things together. So you could do -R and then add the -X to give you hexadecimal output based on what it's reading inside the PCAP file, right? So TShark R demo PCAP will read that PCAP file and it'll go all the way and give you all the details. If you do TShark R demo PCAP C2, it'll count and it'll just give you the first 2 packet captures and it stops after the first 2. If you could do TShark R demo PCAP count 1 and then W on the demo PCAP, it'll write it to a new PCAP file for you. So it'll read this one, take the first packet, and then write that into a new PCAP file. And then they're just running ls to see that there's an actual demo PCAP, and then you can read the demo PCAP and you'll see that it only gives you that 1 entry. Packet bytes, so read the packets right here. You see all of that. If you read it with X, as we mentioned already, it gives you the packet bytes. So the hexadecimal and the AC format of everything that's inside of that packet and all of the traffic that's been captured. If we do R count 1, it still gives you that 1 count, that 1 packet. If you do R count 1 in verbose mode, you'll notice that instead of just it giving you these basic lines right here, you get a lot of more information that comes out of that one single packet that we're displaying, including the length of the packet, any flags that have been turned on, time to live 128, the type of protocol that it's running, the source IP address, the destination IP address, a lot of great information instead of just giving you this kind of basic information right here where if you know how to read these things, you'll know that this is the source IP and this will be the destination IP and that's the protocol, that would be the port, etc., or the source port, destination port, right? If you know how to read these things, you can kind of decipher what that means. In this particular case, it literally tells you source IP is this, destination IP is this, and it'll probably keep telling you what the source port is and what the destination port is. So it helps you read the contents of the packet in a much easier way, which is why verbose mode is typically, if I know that something offers verbose mode, I will usually just run it in verbose mode because it gives so much more details about it and it's just super freaking useful. And this is a comparison to the TShark CLI versus the WireShark GUI. So if we were to open a single packet in WireShark and open up the Internet Protocol portion of it and the TCP transmission control protocol portion of it, it's very similar to what you would see inside of the command line with TShark if you do verbose, right? So if you don't do verbose, you're not going to get that information. But if you do verbose, it actually gives you all of the details that you would see if you were actually looking at it inside of WireShark and just breaking down each one of these portions individually themselves. So it's very, very helpful and probably, hopefully, much quicker than running WireShark and the GUI platform. So now what we're going to do is we're going to read the the demo PCAP file with TShark and find the TCP flags that are in the 29th packet and then the ACK value of the 25th packet and the window size value of the 9th packet. So as you can imagine, we're going to be looking at the count parameter. So we're going to count until the 29th packet just so we can see that 29th packet, and we're going to see the TCP flag. So we're going to do the verbose output for this one. Same thing, we're going to do verbose output and we're going to do verbose output in all of those just so we can get all of these details. But we're using the count parameter just so we can get the 29th, 25th, and the 9th, right? So I could technically just print all of the 29 and then go up to 25 and then go up to 9, but we want to get good at writing these commands, so we're going to do multiple versions of that, right? So here's what we got over here, and I'm going to clear my screen and we're going to start from the very top. So we're going to do TShark R PCAP, or excuse me, let's see, what is it? I think, what was the name of the file? Demo, there we go, demo PCAP, there we go. We're doing that, and we're going to do verbose, and then we're going to see, and we're going to count to 29. So it's going to give us the 29th. This very last piece would be the 29th packet. So if I go up here, it should be the 29th packet. So let's see if we can actually get that information. There we go. So frame 29, and it gives us all the information about it. So the question that they had was, what do we need from the 29th? We need the assigned TCP flags in the 29th packet. So let me find those flags. And we find that under the transmission control protocol portion of this thing. And if you come down here for flags, you'll see inside the parentheses, it gives you 2 flags for this particular packet, which is the, I believe that's the push and the acknowledgement packet. So PSH and ACH would be our answers. So we're going to do PSH, ACK, and PSH. All right, there we go. That's the right answer. Now the 25th packet. So what's the ACK value of the 25th packet? So we're going to go back over here. And essentially what I'm going to do is I'm just going to press up, and it's going to bring me the very last command. And I'm just going to count to 25 and get the very last one. And now we want the ACK value of this particular packet. And this is actually under transmission control protocol as well. So if I kind of pull this out a little bit, it's a little bit easier to see it at the top right here, because you can see it right at the very top where it says ACK 12421. But then there's also a section right here where it says acknowledgement number, which is 12421. So both are the same exact value. So we're going to go back over here, and then, whoops, what was it? So it was 12421. And there we go. That's that answer. So what is the window size value of the 9th packet? So we're just going to press up. It's going to bring us the command again, and we're going to do count to 9, and we're going to get the 9th value. And right there, so window size value 9660 for that one. That one showed up right on the screen, and we got it. So there is our answers for the main parameters. So pretty straightforward, pretty useful if you know how to use some of those basic parameters, basic command options right there. So that's what we got so far. Let's move on to the next one for capture conditions. Real quick before we move on to task number 5, I wanted to tell you about Hackaholics Anonymous. This is our membership community that's available on this channel, and I really think that you'll get a lot of value from it. There are a lot of different perks that are available. There are 4 tiers of the memberships that are available, and if you haven't checked it out already, I think you would be surprised pleasantly about how amazing Hackaholics Anonymous can be, and I would just love to see you in our Discord chats and in our membership community. So if you haven't checked it out already, definitely check it out. All right, let's move on to task number 5. We already know that TShark has the ability to capture traffic and sniff traffic, so there are some parameters that we can use to actually make that happen. So define capture conditions for a single run or loop, stop after completing the condition, also known as auto stop. So that's what this whole thing, all of these things are going to do. So the first one is -A. And the duration would be to sniff the traffic and stop after X seconds, create a new file, and write output to it. So you do TShark W to write to the test PCAP, and then the A would be auto stop for the duration to be 1. So after a certain number of seconds, I guess, I don't know if the 1 is 1 minute, or maybe 1 packet has been captured. Or this could be 1 second. Probably I think the X represents the 1 second. So it captures for 1 second, I would assume. File size in this particular case. So define the maximum capture size after, and then stop after reaching X file size. So write to the test PCAP, all of this is going to be the same. And then the file size is going to be 10. So when you reach 10 kilobytes, stop writing and stop running. Files would be the maximum number of output files, stop after X files. So write to the test PCAP, file size 10, and then files 3. So that's actually really useful to know. So it's going to create 3 files for you. I guess it would be test 1, test 2, something like that. And then the file size of each file is going to be 10 kilobytes. And then we have the ring buffer control option, define capture conditions for multiple runs or loops. It could be an infinite loop, right? So the duration in this particular would be 1. So sniff the traffic for 1 second, create a new file, and write output to it. I guess B1 would mean that it just runs for a second and reruns. I'm not exactly sure what that means. This one would be file size is 10. So essentially everything is the same with the exception that the option is B, and it would run multiple runs or multiple loops, creating an infinite loop. And that part is a little bit confusing to me. So let's see what the hint says right here. So TShark supports combining auto stop with the ring buffer. You can combine the parameters according to your needs. Use the infinite loop option carefully. Remember, you must use at least one auto stop parameter to stop the infinite loop. Okay, that kind of makes sense, because if I guess if you don't use the auto stop, it's just going to keep running and probably create a bunch of files inside of your computer. So that probably is not a good idea. In this case, it's going to start sniffing the traffic and stop after 2 seconds, and then save the dump into 5 files, each being 5 kilobytes. So it's going to write into auto demo pcap, and then the duration is going to be 2 seconds. File size is going to be 5, and then files would be 5, and then it's just, that's it. It's running and it's capturing, and then it's going to create these various pcap files for you, 1, 2, 3, 4, 5, right? So this one is all using the A auto stop parameter. We don't have an example of the B infinite loop parameter, but I guess you technically don't need it. Like if you know exactly how many files you want, how many replicas or duplicates of the files you want, how many various captures you want, I don't think you need to create a loop, because technically you could just say, you know, do all of this and then stop at file 10, or do all of this and stop at file 100, right? And it would still work, and it would keep creating various files for you until it's done. So I would just rely on the auto stop function, not to create an infinite loop, unless you really know what you're doing, and I don't. So I don't want to do anything crazy here and make my VM crash in this particular case. So what we have is which parameter can help analysts to create a continuous capture dump, and that would be the B. Whoops, it needs to be a -B, and that's the continuous infinite loop. And can we combine auto stop and ring buffer? You can indeed. That's all the questions that they had for us. So I guess we don't need to run any capture exercises right now. Maybe we'll do it in the future, but for now we just needed to know what these capture conditions were. So let us move on to the next piece here, which is the packet filtering options, capturing versus display. There are 2 dimensions of packet filtering in TShark. There's the live dimension, which is for capturing, and then post capture, which would be the displaying of those 2 various instances, I guess. So you would either capture or you would display, right? These 2 dimensions can be filtered with 2 different approaches using a predefined syntax or Berkeley packet filters. I remember these guys. These are technology used in certain computer operating systems for programs that need to, among other things, analyze network traffic. BPF supports filtering packets, allowing its user space to supply a filter program that specifies which packets it wants to receive. Got it. TShark supports both. You can use WireShark filters and BPF to filter traffic. As mentioned earlier, it's a command line version of WireShark, so we will need to use different filters for capturing and filtering packets. A quick recap from WireShark Packet Operations Room. So you have the capture filters, which is a live filtering option. It's to save only a specific part of the traffic, and it's set before capturing the traffic, and it's not changeable during the live capture. Display filters are post capture, and just like the name implies, they filter the display after the packets have been captured, so that you only see the number of visible packets that you're interested in, which is changeable during the investigation. So you can change your display filters as you're going through your investigation. Capture filters are set once, and then the capture begins, and then you can't change it during that capture. Capture filters are used to have a specific type of traffic in the capture file rather than having everything. They have limited filtering features, and the purpose is to implement a scope by range, protocol, and direction of filtering. This might sound like bulk raw filtering, but it still provides organized capture files with reasonable file size. The display filters investigate the capture files in depth without modifying the packet. The F parameter stands for the capture filters, same as the BPF syntax and WireShark's capture filters. The Y, capital Y, parameter display filters, same as the display filters in WireShark. So the packet operations video for WireShark will show you a lot about the principles of packet filtering, either in the capture filters or the display filters. And that is, again, part of the videos that we recorded for WireShark, and those are actually available on this channel as well. So let's get to these things. It says which parameter is used to set capture filters, and as we can see on the screen, it is the F parameter, and display filters are used with the Y parameter. So easy does it, easy money. Moving on to the next one, filtering options for the capture filters. All right, we have these two sources. So there's the PCAP filter from wireshark.org, and then there's a GitLab repository as well for a bunch of filters that are available for WireShark and their capture filters. So these are external sources outside of TryHackMe, but they are actually very useful, and you can probably just find those by Googling as well. So if you do WireShark capture filters on Google, you will most likely find those same exact links as well. The type of the qualifier for the capture filters here looks like this. So we have the filtering a host. So you have host, net, port, and port range would be your options. Filtering a host would be TShark F, and then you put all of this in quotes where you say host and then the IP address. Filtering a network range, so same thing. The TShark F part is going to be exactly the same with each one, and then you put all of the options inside of quotations, as you can see. For a network, you would say net, and then you do the first 3 series inside of the subnet, and then you leave that last one as a 0, and you do a -24. This is where the networking understanding actually helps a lot. And so what it does is that it looks at everything inside of this range, with the only thing that changes is this portion at the end right here, and it goes from 0 to 255 from what I remember. So it'll give you 10, 10, 10, 1, 10, 10, 10, 2, 10, 10, 10, 3, 10, 10, 10, all the way up to 255. Filtering a port would be port 80. So it just looks at everything inside of that port 80. And then port range would be the initial port dash the ending port. So the beginning and then the ending separated by a hyphen or a dash. So that is what the capture for these various ranges are. So host, network, port, and then port range. And then we have the direction. So you have a source and a destination. So if you want to filter the source address, you would say source host this, and it would look at everything that has this IP address as the source. And then if you want that IP address as the destination, you would say destination host that. So you can imply to which amount of traffic you capture based on who you want the source host to be and who you want the destination source to be. And then we have the target protocol. So you can have the ARP address resolution protocol. You can have the Ethernet, ICMP, IP, IP6, TCP, UDP. All of those things can be as your target protocol. And I guess all you got to do is just put it inside the quotes, right? So for TCP, you would just do TCP inside the quotes. You could probably do UDP inside the quotes as well. If you want a MAC address specifically, you would do Ethernet, because Ethernet addresses are the MAC addresses. So you would do Ether and then the host, and then you provide the MAC address that you want to be tracked and filtered. You can also filter protocols with IP protocol numbers assigned by IANA. So as a standard organization that oversees global IP address allocation, autonomous system number allocation, root zone management in the DNS, media types, and other internet protocol related symbols and internet numbers. And then we have the IP protocol 1, for example, where you would be IP proto 1, which in this case would be ICMP. Then we have the assigned internet protocol numbers, which is actually probably a very useful tool here, that it will tell us what all of these various things are and how they are assigned, because these are not the port numbers, right? So these are the actual protocol numbers that have been assigned to these things. So TCP is 6, and let's see what else we can find here. UDP is 17. The ones that I recognize, the ones that are the ones that I would probably be displaying here. IPv6 is 41. IPv6 route, IPv6 fragmented, all of these things, most of these I actually don't recognize. So it goes to show you that I need to study up on my networking as well. But this is a tool from IANA, the Internet Assigned Numbers Authority. And these are the guys that have these assigned decimal numbers for these protocol versions or protocol IDs, I guess. I think that's what that would be. But yeah, that's it. That's how you can filter by protocol as you capture your data. So there is something called the Terminator. The Terminator terminal instance to have a split screen view in a single terminal. And the Terminator will help you craft and sniff packets using a single terminal interface. Now run the Terminator command and follow the instructions using the new terminal instance. And so that's what it looks like right here. So very interesting. So I actually want to do this. This is not something that I have done before, so I'm really excited about doing this. So what I'm going to do is I'm going to open this on a second screen, and then we're actually going to run it, and we're going to capture it and see what we can get over here. So let's go over here, and we're going to zoom in a little bit. Okay, so let's clear this up. We're going to do Terminator. Sick. Interesting. Okay, let me zoom out and get that back onto the screen like so. Alright, so this is our Terminator instance of the shell. Very, very cool. So we have the top, we have the bottom portion. So in the top portion, it's saying to scan any given IP. So I guess I'm just going to use the IP that has been assigned to us. So we'll do TShark F, and then we'll do host 10.10.140.251, which is the IP that I've been assigned. And so that's going to start capturing, and it is capturing. And then we're going to go over here, and we're going to do a curl v 10.10.140.251 and run that. And we got that. And then what do I do? Right? Being comfortable with this, you can use the table to do practice TShark filters. So I'm going to stop this running because it seems like it's just running. And I wonder, I should have probably done like an output so we can try to capture that instance as well to see what we can get. There should be some kind of a HTTP request that has been done using our curl command inside all of this data. And I wonder if I can even use that. Can I search through this? I can't search through it. So this is interesting though. Like I've never done this before. I've never used Terminator. So this is actually really interesting that we can do this. I just have never done it. So that one is kind of cool. Okay, so what they're telling us to do is we should be able to use these capture filters. So being comfortable with the command line and TShark filters requires time and practice. You can use the below table to practice the capture filters. So capturing traffic to or from a specified host, traffic generation with curl. This command sends a default HTTP query to a specified address, for example, tryhackme.com. TShark capture filter for a host would be fhost. Oh, you can also do a domain name, so you don't necessarily have to do an IP address. That's actually good to know. IP filtering involves traffic to or from a specified port, and we can use the netcat tool to create noise on specific ports. Traffic generation with netcat. Netcat in this case creates a verbose connection to this particular piece with a timeout of 5 seconds. So it creates a netcat connection to this specific IP address on port 4444, and it will do a 5-second interval, right? Where it provides the details to this particular IP from the IP address that you're on, and it will do a interval of 5-second data delivery. The TShark capture filter for that IP address would again run at the same time. So this would happen first, and then you run capturing on TShark for that specific IP so that you can see what's going on. So we can do a variety of these things to track with TShark. Another one is traffic generation with netcat on the port IP, so or the port address, excuse me. Port address is also not the right word. Port number probably is the right word. So in this particular case, we were capturing on the host. In this case, we're capturing on that specific port, which will probably be better because there shouldn't be too many traffic connections being made on this random port number. And then we have protocol filtering. So netcat UDP is the U flag right here. And again, same thing, every 5 seconds is going to send it, and then you would filter with the UDP filter to capture that. So run the commands from the above terminator terminals on the target machine and answer these questions. What is the number of packets with SYN bytes? So let's see. So I'm actually going to rerun basically the commands that we had over here. But the one thing that I want to do is I want to create an output file so that I can try to analyze the traffic a little bit easier. And I think that would probably be the best way that we can do this. So it doesn't specify which various commands to run inside of the terminator. It just says to run what we see inside of the above terminal. Run the above terminator terminals or above terminator terminals on the target machine. Yeah, so that's the only thing that it shows right here. So in this particular case, I'm going to run this again, same exact thing on the host, but then I'm just going to do a write command, and I'm going to put it inside of the test pcap file just so we can see what the output is going to look like. And then down here, we're just going to rerun our curl command, and you can see it's already in the thousands over here. And the curl command has been run again, so it's all good. So now I can just stop this thing from running, and there should now be a pcap file, a test pcap file. We have that. So we'll just go over here, and what I'm going to do in this case, if I close that, oh, it closes the terminator altogether. But I do have a test pcap file now. So what I can do in this case, I can search through my test pcap file and try to pull these various SYN packets, essentially, is what we're trying to do. And we want to see how many of those things there are. So I'm going to combine a few of the command line hints that we got at the very beginning while we were grepping, and we're trying to find specific unique values, so on and so forth, right? So I'm going to run a few different commands to see if I can actually find the data that we're looking for. So let's see what we can find. Okay, so after actually running this a few times and trying to search through that document, I actually found out that I think I'm supposed to be running them on this IP address instead of the actual IP address of the virtual machine that we've been given, which is this IP address. That's what I've been scanning this whole time. So what I'm going to do, I'm going to run Terminator again, and I'm going to run these various commands, these two commands again, and instead I'm just going to use the 10.10.10.10 IP address instead of the one that is actually belonging to this specific machine. So hopefully this time I'll actually be able to get some SYN packets that I can count, because I grepped through it and I couldn't even find the SYN packets, the number of the SYN packets. So let's see, let's try that one more time. Yeah, and this time it actually wasn't constantly capturing traffic either. It actually just started and nothing was happening until I ran the curl command. And when I ran the curl command, it showed me the various SYN packets. So here's what I'm going to do. I'm actually going to stop this, and I'm going to rerun it again, and I'm going to write to a test1 pcap, so a new pcap file. I'm going to run that, and it's going to capture it, and it's going to run it, and it will run the curl command one more time. And then there we go. We got 12 entries, as you can see, and then it just stopped running, so there's no more entries being captured. So I can stop that one and then go back over here, and we can stop this thing right here. And now we can do TShark to read our test1 pcap, and then from there we can grep for SYN, and let's see what we get. We get 2 instants that show up right away. I wonder if that's actually the right answer. So let's do that. These aren't this is the page. I'm super zoomed in here. So let's see if 2 is the right answer. Yeah, it is the, okay, great. Great. So what is the number of packets sent to the IP address 1010.10.10? So we want the IP address to be destination 1010.10.10. So that's what we're going to look for. So let's read through this one more time. Instead, what we're going to do now is, instead of grepping SYN, we're just going to read through it. And then what we're looking for is the 1010.10.10 IP address to be the destination IP. So this is the source, and then after the question mark would be the destination IP. So we have 1 is the destination IP, 2, 3, 4, 5, 6, and 7. I got 7. So let's try 7. Very good. And what is the number of packets with ACK bytes? So I have this on the screen already, so I'm just going to do that. So I got 1, 2, 3, 4, 5, 6, 7, and 8. I got 8 with ACK bytes. So let's try that. All right, cool. There we go. The biggest thing was I actually had to run it against 1010.10.10 instead of running it against my own virtual machine IP that's been assigned to me in this case. So, all right, cool. Very good. That one's in the bag. And moving on to the very last exercise. And display filters are now going to be the ones that we're going to look at. And we do have the WireShark reference document that shows you a lot about the various display filters that are available in WireShark. And it's very similar to the packet operations room and just the WireShark GUI in general. For example, if you do ip.addr, so IP address, it'll show you anything that has to do with the source or destination address being that IP. If you do IP source, in this case, it'll show you only the traffic that has to do with that being the source, and an IP destination, only the traffic that has to do with that being the destination. You can also do a network range, very similar to what we had in the capture, where you just leave off the last segment and subnet, and in this particular case leave a 0 and just do /24, and it shows you everything that has to do with this intro, and then the rest of it, any extension of that specific IP address. And same thing for protocols, so TCP port 80, TCP source port, or TCP destination port 80, all of those things still work. We can do HTTP as a protocol, so instead of DNS, for example, or ICMP, you can just search for an individual protocol and just show those. And then if you want to look for a response code and only the successful responses that came in, which would be HTTP 200 response code, all of that is possible as well. And then filtering DNS packets as well, right? So DNS query type 1, needing to know what it actually means. So you need to know what all the query types are and how they relate to WireShark queries, but then you can also do that as well where you do a DNS query type 1 or a variety of other DNS query types that are available. So there's a lot more options. Obviously, if you look at this document, there's a lot of options that are available here for filtering through displays or display filters through WireShark. So that one is a big one, and there's a lot of options that are available. So what we're going to do in this case is we're going to use the demo pcap file to test these display filters, and we're going to search for a variety of various queries. So IP address in this case, and it will show you the number of queries. I don't know if this is all of them. It seems like there was only 2 that has to do with that. And then this one for the HTTP queries that are available inside of that specific file, HTTP new line, or number line, I think not new line, number line. So it shows you the number of the line that that query exists on inside of the packet. So this one's on line 4, this one's on line 18, 27, 38, so on and so forth. So we're going to use the demo pcap file to answer these last set of questions here. So for the first question, it says, what's the number of packets with a specific IP address that starts with that 65, and I think the NL actually counts the number of lines. So I don't think it shows you the number of the line that's on there, because inherently it just shows you that. But I do believe that it counts the number of lines. So if I do the demo pcap reading, and then if we do a capital Y, and in this case we're going to do ip.addr equals the IP address that they want from us, which is in this case 65.822.8.223, and then we do that, and then we just pipe that into NL to give us the number of the lines. And so from what I understand, this is actually 34 entries. So that's what that does, and it gives you the various numbers of the lines that those things are on inside of the actual log file itself, inside of the capture file itself. But we have 34 counted, so that should be our answer. So let's try that. Yeah, it is. Excellent. Okay, so that is how it works. So now it says, what is the number of packets with a TCP port of 3371? So pretty much same concept, except now we're going to look for the TCP port 3371. Oh, I forgot to count it, so let's do that and do that. And now we have 7, so let's try that here. Excellent. So what is the number of packets with this IP address as a source address? So very, very similar to what we did, except now we're just going to change it to searching for the source address. There we go, and we got 20 of those, so we're going to run that over here, and there we go. Now rerun the previous query and look at the output. What is the packet number of the duplicate packet? So the same thing, and look at the output now. What is the packet number of the duplicate packet? So we have TCP dupe acknowledgement. I believe that's the one, so that's packet 17, and I can't see anything else that actually has a duplicate packet in it. So 17 would be the one. That would be my guess. Oh, it's not. Okay, so let's see what else we got. Actually, I was totally right. I'm reading the wrong thing. So this is the count. This is not the packet number. So this is the duplicate packet. That's the right one. But it's not 17. It's actually 37 is the packet number. That is my bad. I was misreading this thing entirely. Okay, so there we go. That's the right answer. And that's it. That's it for our exercises for the introduction to TShark. All right, if you found this video useful and if you would like to get more videos like this one, I definitely do encourage you to check out our channel and like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. There's a lot of great stuff on here. There's the original SOC Level 1 playlist that has all the original videos on it, and then there's all the additions that we're going to be making as we go along and update that playlist together. So if you want to get the rest of the stuff on TShark and the rest of the stuff on all the missing videos for SOC Level 1, I do encourage you to like, subscribe, and turn on the notification bell. Or if you just want to get anything else about cybersecurity and ethical hacking, I think you would like this channel. So hopefully I will see you in our comment section, because we have a very live comment section. There's a lot of people that drop a lot of comments and they ask a lot of questions, and I am very responsive. And if you actually have a really good question, I will make a video dedicated just to your question. So on top of liking, subscribing, and turning on that bell, I would recommend that you drop a comment if you have any questions, because I am responsive and I do make videos if you have a really good question. So hopefully I'll see you in the comment section. And I do gotta remind you about Hackaholics Anonymous, because it is going to be the premier YouTube community for security professionals and hackers, mainly because of the fact that I really want it to be, and I put a lot of work into this community, and there's a lot of perks that are attached to it. So we have the downloads that are exclusive to our members, we have the content exclusive to them, we have the bug bounties that we go in on together to make money, there's the Python automations that we give away at the end of every single month, there's the Discord chat, there's the discount on merch, there's so much stuff that's available, and there's 4 tiers of memberships that are available, just to kind of give you options for you to choose from in case one doesn't work for you and you want something else. So if you haven't checked it out already, I really recommend you check it out. It's on our homepage. You can watch the video, or if you click on this read more button, it'll open it up in a new window and you can read through the description that also has a breakdown of all the perks that are available. And I would love to see you in the Discord chat, and I would love to see you in a part of the Hackaholics Anonymous membership community. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video later.